Friends. Now software project management. Here we are studying. Now we are studying the software project management. The overview is introduction, technical plan, software process models, selecting process model. The definition: software process, the set of activities, method, and practices that are used in the production and evolution of software. Software process model, one specific embodiment of a software process architecture. Why modeling? To provide a common understanding, to locate any inconsistencies, redundancies, and omissions, to reflect the development goals and provide early evaluation, assist the development team to understand any special situations. Project analysis methodologies are used: object-oriented development, structured system analysis and design method, Jackson structured programming technologies, application building environments, knowledge-based system tools. The project characteristics: data-oriented or control-oriented system, general package or application specific, a particular type of system for which specific tools have been developed, safety critical system, nature of the hardware or software environment. Project risk: there are product uncertainty, process uncertainty, and resource uncertainty. Consideration for project approach: control system, information system, general applications, specialized techniques, hardware environment, safety critical system, and emphasize requirements. The teaching plan is contents, constraints, approach, implementation, and implications. The teaching plan constraints are the character of the system to be developed, risk and uncertainties of the project, user requirements concerning implementation. Teaching plan approach: selected methodology or process models, development methods, required software tools, target hardware and software environment. Teaching plan implementation: development environment, maintenance environment, training. Teaching plan implications: the project products and activities, effort on schedule, duration and overall project effort. Financial: a report used to reproduce costings. Software process models: waterfall model, V model, spiral model, and prototyping model. Software process models are also there are phase development model, in that incremental development model, iterative development model, operational specification model, and transformation model. Here is the waterfall model: the requirement analysis, system design, coding, testing, and maintenance. These 5 phases are comes one by one, but here when first phase completed, then we can go to the second phase. The waterfall model contains a classical one-shot approach, effective control, limited scope of iteration, long cycle time, not suitable for system of high uncertainty. Here, the V model. In the V model, there is a requirement analysis, system design, program design, coding, then unit and integration testing, system testing, user acceptance testing, and maintenance. Here, all are connected to each other. The V model contains additional validation process introduce relate testing to analysis and design, loop back in case of discrepancy. Spiral model. In the spiral model, here is the diagrammatical representation where there are four parts are considered in spiral. First one is determine objectives or alternatives and constraints, plan the next phase, develop and verify next level product, evaluate alternatives, identify and resolve risk. Here, in spiral model, evolutionary approach, iterative development combined with risk management, risk analysis result in go, REDO, no go decision. Spiral model contains four major activities: planning, risk analysis, engineering, and evaluation. Here are the prototyping model. The goal is meet user requirements at an early stage, reduce risk and uncertainty, verify a design or implementation approach, should always answer specific questions, goal must be identified. Classification of prototype, throw away after users agree the requirement of the system, the prototype will be discarded. Evolutionary modifications are based on the existing prototype. Incremental functions will be arranged and built accordingly. The prototyping model diagrammatical representation is build a prototype, user satisfaction. If yes, go. If no, then user feedback and come back to first step. Benefits of prototyping: learning by doing, improved communication, improved user involvement, clarification of partially known requirements. Prototyping sequences: requirements gathering, quick design, prototype construction, customer evaluation, refinement, loop back to quick design for the fine tuning, and product engineering. These are the benefits of prototyping, that is demonstration of the consistency and completeness of a specification, reduced need for documentation, reduced maintenance cost, feature constraints, production of expected result for testing real system. These are the drawbacks of prototyping. Users sometimes misunderstand the role of the prototype, lack of project standards possible, lack of control, additional expense, machine efficiency, close proximity of developers. Forms of prototypes: mocks ups, simulated interaction, partial working model. Prototype products: human computer interface, system functionality. Prototype changes: there are three categories: cosmetic 35%, screen layout, local 60%, screen processing, global 5%, multi-parts processing, and design review. This is the phase development. Reduce cycle time to parallel system. Operational system, that is release n, development system, that is release n plus 1. Two approaches: incremental and iterative. The phase development is having two approaches. First one is incremental and iterative. We will see these approaches in the next lecture. Thanks for watching the video.